Howdy, this is the Ultrasonic Levitator setup. On this bottom part, this bottom piece, we have a speaker that produces high frequency sound waves, and this top part is a reflector panel. So now I'm going to levitate some styrofoam balls. The speaker is producing a high-frequency sound wave that is reflected by the reflector panel. So the sound wave is bouncing between the speaker and panel repeatedly and forms a standing wave. The standing wave has two regions. One is a high-pressure band, which is where the styrofoam balls are floating, and there is a low-pressure band, which is in between the styrofoam balls. This happens because the speaker is a distance of a multiple of 1/2 the wavelength from the panel. Because we can't see the standing wave with our naked eye, there is a technique called Schlieren Optics in which we can visualize the standing wave, and that is what we're going to explain next. The Schlieren setup consists of 3 portions. The first portion is a bright light, in our case it is a bright LED. The second portion is a spherical mirror of long focal length. In our setup, the focal length is about 1 meter. The third portion consists of a camera with a light block attached to it. First, the light emerges from the pinhole. The light then goes through the standing wave and is reflected off the mirror. The light goes back and is directed into the camera. The light must first go through the light stop and is then captured by the sensor. When the light goes through the standing wave and is bounced back by the mirror, the light is refracted. This is because of the presence of high and low pressure bands. The refractive index of air changes vertically, causing the light to refract. When the light reaches the light stop, most of the light is blocked and only allows the refracted light to go through and reach the sensor.
Okay, so I'm going to show you all that the styrofoam balls are going to float in the higher pressure areas. You can see that the styrofoam balls are only floating in the white bands, which show the high pressure nodes. We know it's high pressure because those bands appear right under the reflector and right above the speaker. The distance between the speaker and the plate is a multiple of 1/2 of the wavelength of the sound wave, which gives the ability to see the waves. As you move the height up and down, the waves will disappear, but they will again reappear at a new multiple of 1/2 of a wavelength. We'll move the height to show you what it looks like when the standing waves disappear and again when they reappear at the new multiple of 1/2 of a wavelength. At this height, the standing waves have reformed as the distance from the speaker to the plate is another multiple of 1/2 of a wavelength. Once again, you will be able to float the styrofoam balls in the high pressure nodes where the white bands are seen. The reason one can see 2 styrofoam balls instead of 1 is because of the ball itself and the other one that is the image from the mirror. This demonstration is meant to show how the standing waves can form when the distance from the speaker to the plate is any multiple of 1/2 of a wavelength.